various concentrations of hydrochloric acid using pH paper or universal indicator. In this experiment, we will determine the pH values of various concentration of hydrochloric acid using pH paper or universal indicator. Theory: acidic nature of an aqueous solution is due to presence of hydrogen ions, while basic nature is due to the presence of hydroxyl ions. pH is defined as a negative logarithm to the base 10 of hydrogen ion concentration. pOH is defined as a negative log to the base 10 of hydroxyl ion concentration. pH plus pOH is equal to 14. For a neutral solution, pH is equal to 7. For an acidic solution, pH is less than 7. For a basic solution, pH is greater than 7. pH of a solution can be determined using pH paper or universal indicator. The pH scale table shows the hydrogen ions of hydroxyl ions concentration and their corresponding pH and pOH. To perform this experiment, the apparatus required are 100 ml volumetric flask, 250 ml beaker, 10 ml pipette, test tubes with a test tube stand and a dropper. The chemicals required are 0.1 molar hydrochloric acid, distilled water, pH paper strips, standard pH color chart, and universal indicator. Let us perform the experiment. Label 6 clean test tubes as A, B, C, D, E and F. Take 10 ml of 0.1 molar hydrochloric acid in test tube A. Now, let us prepare 10 raised to minus 2 molar, 10 raised to minus 3 molar, 10 raised to minus 4 molar, 10 raised to minus 5 molar, and 10 raised to minus 6 molar hydrochloric acid using the given 0.1 molar hydrochloric acid. Preparation of 0.01 molar, that is 1 multiplied by 10 raised to minus 2 molar hydrochloric acid. Pipette out 10 ml of 0.1 molar hydrochloric acid solution in a clean 100 ml volumetric flask. Dilute the solution to 100 ml mark using distilled water and shake well. Concentration of the solution will be 0.01 molar, that is 1 multiplied by 10 raised to minus 2 molar hydrochloric acid. M2 into V2 is equal to M1 into V1. Therefore, M2 is equal to M1 into V1 upon V2, which is equal to 0.1 into 10 upon 100, which is equal to 0.01 m HCl. Transfer 10 ml of this 0.01 molar hydrochloric acid solution from the volumetric flask in test tube B. Rinse a 250 ml beaker with 0.01 molar hydrochloric acid. Transfer the 0.01 molar hydrochloric acid solution from the volumetric flask to the beaker. Now, wash the volumetric flask with distilled water. Preparation of 0.001 molar, that is 1 multiplied by 10 raised to minus 3 molar hydrochloric acid. Pipette out 10 ml of 0.01 molar hydrochloric acid solution into the washed volumetric flask. Dilute the solution to 100 ml mark using distilled water and shake well. Concentration of the solution will be 0.001 molar, that is 1 multiplied by 10 raised to minus 3 molar hydrochloric acid. M2 is equal to M1 into V1 upon V2, which is equal to 0.01 into 10 upon 100, which is equal to 0.001 m. Transfer 10 ml of this 0.001 molar hydrochloric acid solution from the volumetric flask in test tube C. Rinse a 250 ml beaker with 0.001 molar hydrochloric acid. Transfer the 0.001 molar hydrochloric acid solution from the volumetric flask to the beaker. Now, wash the volumetric flask with distilled water. Preparation of 0.0001 molar, that is 1 multiplied by 10 raised to minus 4 molar hydrochloric acid. Pipette out 10 ml of 0.001 molar hydrochloric acid solution into the washed volumetric flask. Dilute the solution to 100 ml mark using distilled water and shake well. Concentration of the solution will be 0.0001 molar, that is 1 multiplied by 10 raised to minus 4 molar hydrochloric acid. M2 is equal to 0.001 into 10 upon 100, which is equal to 0.0001 m, which is equal to 1 into 10 raised to minus 4 m HCl. Transfer 10 ml of this 0.0001 molar hydrochloric acid solution from the volumetric flask in test tube D. Rinse a 250 ml beaker with 0.0001 molar hydrochloric acid. Transfer the 0.0001 molar hydrochloric acid solution from the volumetric flask to the beaker. Now, wash the volumetric flask with distilled water. Preparation of 1 multiplied by 10 raised to minus 5 molar hydrochloric acid. Pipette out 10 ml of 1 multiplied by 10 raised to minus 4 molar hydrochloric acid solution into the washed volumetric flask. Dilute the solution to 100 ml mark using distilled water and shake well. Concentration of the solution will be 1 multiplied by 10 raised to minus 5 molar hydrochloric acid. M2 is equal to 1 into 10 raised to minus 4 into 10 upon 100, which is equal to 1 into 10 raised to minus 5 m HCl. Transfer 10 ml of this 1 multiplied by 10 raised to minus 5 molar hydrochloric acid solution from the volumetric flask in test tube E. Rinse a 250 ml beaker with 1 multiplied by 10 raised to minus 5 molar hydrochloric acid. Transfer the 1 multiplied by 10 raised to minus 5 molar hydrochloric acid solution from the volumetric flask to the beaker. Now, wash the volumetric flask with distilled water. Preparation of 1 multiplied by 10 raised to minus 6 molar hydrochloric acid. Pipette out 10 ml of 1 multiplied by 10 raised to minus 5 molar hydrochloric acid solution into the washed volumetric flask. Dilute the solution to 100 ml mark using distilled water and shake well. Concentration of the solution will be 1 multiplied by 10 raised to minus 6 molar hydrochloric acid. M2 is equal to 1 into 10 raised to minus 5 into 10 upon 100, which is equal to 1 into 10 raised to minus 6 m HCl. Transfer 10 ml of this 1 multiplied by 10 raised to minus 6 molar hydrochloric acid solution from the volumetric flask in test tube F. Rinse a 250 ml beaker with 1 multiplied by 10 raised to minus 6 molar hydrochloric acid. Transfer the 1 multiplied by 10 raised to minus 6 molar hydrochloric acid solution from the volumetric flask to the beaker. Now wash the volumetric flask with distilled water. Arrange all the test tubes from A to F in the test stand. The pH of these solution can be measured using a pH paper or an universal indicator. Using pH paper, dip a small strip of pH paper into the test tube A. Observe the color developed on pH paper. What do you observe? The pH paper turns red in color. On comparing this red color with the pH color chart, we can say the pH of 0.1 molar hydrochloric acid is 1. Similarly, we can find the pH of the remaining concentrations of hydrochloric acid. For test tube B, the pH paper turns orange-red in color. For test tube C, the pH paper turns orange in color. For test tube D, the pH paper turns yellowish-orange in color. For test tube E, the pH paper turns yellow in color. For test tube F, the pH paper turns greenish-yellow in color. On comparing these colors with the standard pH color chart, we can say pH of 0.01 molar hydrochloric acid is 2. pH of 0.001 molar hydrochloric acid is 3. pH of 0.0001 molar hydrochloric acid is 4. pH of 1 into 10 raised to minus 5 molar hydrochloric acid is 5. pH of 1 into 10 raised to minus 6 molar hydrochloric acid is 6. Using universal indicator, add 2 to 3 drops of the universal indicator to each of the test tubes A to F and observe the color developed in the solution. What do you observe? The solution in test tube A turns red. The solution in test tube B turns orange-red. The solution in test tube C turns orange. The solution in test tube D turns yellowish-orange. The solution in test tube E turns yellow. The solution in test tube F turns greenish-yellow. On comparing these colors with the standard pH color chart, we can say pH of 0.1 molar hydrochloric acid is 1. pH of 0.01 molar hydrochloric acid is 2. pH of 0.001 molar hydrochloric acid is 3. pH of 0.0001 molar hydrochloric acid is 4. pH of 1 into 10 raised to minus 5 molar hydrochloric acid is 5. pH of 1 into 10 raised to minus 6 molar hydrochloric acid is 6. Record these readings in the observation table. Precautions to be taken. Pipetting out of the solution and their dilutions must be carried out very accurately. If you are using the same glass apparatus for the preparation of all the concentrations, ensure it is properly washed after every dilution. Result: as the concentration of hydrochloric acid decreases, its pH increases. It becomes less acidic. If the pH is calculated, it tallies with the observed pH.